Hello, this is Miss Poor, and this recording is for Target Teach for Geometry 203A and 204A as of Thursday, September 18th. And in this recording, I'm going to be discussing some of the topics that I've seen the students struggling with the most in Class Connects and on the quizzes. So let's get started. First, we're going to talk about isometric transformations. Now, the definition of isometry says it's a transformation that preserves the size and shape of an object's original image. That means whenever the transformation takes place, nothing about it changes. And here are three transformations that are always isometric. The first is reflections, and then there's rotations and translations. And what this means, and I've given an example of a happy face down here that could be seen as a reflection or a translation, is that once the transformation takes place, the image looks exactly the same as it did before. Nothing about it changed, especially its shape and its size. Now, a non-isometric or a transformation that is not isometric would be a dilation. As you can see here with these happy faces, I've got a real big one and a real small one. So the size changed, but the shape didn't. Okay? Sometimes the shape will also change. Anytime your size or shape changes, it will be a dilation and it will not be isometric. The next thing I wanted to talk about was the angle addition postulate. Now then, when we think of the angle addition postulate, let's just focus on the addition. Okay, we know what addition means. That means we're adding a couple of things together. Since it's angle addition postulate, that means that we're going to be adding some angles together. So if I have angle 1 and angle 2, correct? I'm going to be adding two, I should say two or more. Let's put that in here, or more. And let me erase that S. Angle measures. All right. Now, what you also need to know what the actual postulate says. Okay, that angle A plus angle B, equals this and that and all that. So you need to know the actual postulate. But I just want for you to reflect on it and put things in your own words, that all we're doing when we're using the angle addition postulate is adding together a couple of angles. Now, when we think about characteristics, there aren't really very many characteristics of an angle addition postulate. So what we're going to say is we're adding, and we're adding using the degree measure of the angles. When we're doing the adding. Some examples, and I've kind of already done one up there at the top. Let's just say I've got angle 4 here, and I've got angle 5 here. I'm going to put a plus sign between them. Okay? And so that's all I'm going to do is add those together. So let's say that, well, let me do this another way. Let me erase that. Let me come back right here. Let's say that the measure of angle 4, let's say that's 110, plus, oops, I don't want a plus sign there. I want to say the measure of angle 5 equals 45. So if I want to add those together, what I'm going to do is take the measure of angle 4 plus the measure of angle 5 and find out what that equals. So I'm going to have 110 plus 45 equals 155. That's all you've got to do, is you're just going to take the angle measures and you're going to add them together. Sometimes there might be more than two angles that are involved, and sometimes you might have to throw in a little bit of algebra. You know, they may tell you what the angle total is and then just give you the measure of one of the angles, and you have to find the measure of the second angle. So always be prepared to work it like that as well. Non-examples are really, even before this lesson I was thinking, what is a non-example? But this would be like segment AB, and then over here you got segment CD. So when I'm talking about angle addition postulate, I'm talking specifically about angles. I'm not talking about any other shape. Sometimes they may give you, let's say I've got this parallelogram, and there's angle 1 and there's angle 2, and they may ask you the sum of those two angles. Looks like we're messing with another shape, but we're still dealing with directly with angles. So just pay attention to what the question's asking you whenever it's asking you for the sum of a couple of angles, because you're going to be using the angle addition postulate. Okay, the other one I wanted to talk about was complementary angles. Now complementary angles, what we're talking about here is the sum of two angles equals 90 degrees. Okay, now then, these angles can be adjacent angles or they can be non-adjacent angles. And remember what adjacent means. They right next to each other. They have a common side and a common vertex, and they're in the same plane. Non-adjacent means one can be on this side of town and the other one can be on the other side of town, but their measures are still going to add up to 90 degrees, no matter where they're at or what they're doing. Okay, they're always going to be 90 degrees. So definition, you got the sum of two angles equals 90 degrees. They can be either adjacent or non-adjacent. Some examples would include, say you've got these, my lines aren't very straight there. See, that's a right angle. And say this angle right here is 50 degrees and this angle right here is 40 degrees. Okay, that's an example of two angles that their sum is 90 degrees. Now I can come over here, say I've got this angle, again with not very straight lines, that's 25 degrees, and then I've got another angle that is right here and it's 75 degrees. Oh wait, does that add up to 90? No, it doesn't. Let's make that 65 degrees. Had to do some quick mental math there. Okay, so I've got those two angles that add up to 90 degrees, but they're non-adjacent. They're still going to be complementary. Okay, complementary angles always add up to 90 degrees. It doesn't matter if they're right next to each other or not. Non-example would be, you've got this angle that's 50 degrees and you've got this angle that's 60 degrees. That's a non-example. If I go like this and I've got this angle down here, let's say that's 45 and this one's 55. There again, we're looking at angles that doesn't matter if they're adjacent or non-adjacent, their sum is not 90. So therefore they can't be complementary. The same ideas that I just talked about with complementary also work with supplementary angles. Okay, so the definition, there's just one little difference. Well, actually it's a big difference. It's a difference that's doubled. Sum of two angles equals 180 degrees. Same characteristics. They can be adjacent, which would make them a linear pair, by the way, or non-adjacent, which means there again we got one hanging out on the north side of town and another one hanging out on the south side of town. Doesn't matter where they're at or what they're doing, they still add up to 180 degrees. And here's you a couple of examples. I always find these kind of hard to eyeball and draw. Let's say this one right here is 120 degrees. This angle right here is 60 degrees. Even though they're not right there together, it does not matter. They still add up to 180. Now, I like it when I have to draw linear pairs because they're easy. Let's say this one's 140 degrees. Well, let's say the bigger one's 140 degrees and the smaller one's 40 degrees. Notice they're adjacent. They're still going to add up to 180 degrees. Doesn't matter if they're together or they're not together. They're always going to add up like that. Non-examples, same thing. Any two angles that I have that are not going to add up to 180. Alright, and then I can even have it like this right here. I am not doing very good with my adding today. There we go. That's a lot bigger than 60 degrees, but you get the idea. You always go by the information you're given, not what the figure looks like. That's a hard and fast rule in geometry. So, but those are two non-examples. So supplementary angles are always two angles that have a sum of 180 degrees. Let me go back. Now what I'm going to do is I'm going to push out a document that will it will confirm your attendance at this Target Teach, and second, it will help me determine if you are learning what isometric transformations are, what complementary angles are, what supplementary angles are, and if you know how to add two angles together. And all you need to do is complete this survey and submit it, and it will be turned in, and I would appreciate it. Thanks for listening, and if you have any questions, be sure to IM me at tpoor_txva or shoot me a K-mail. Thank you. I have put the link for the doc in the chat box. All you need to do is click on that to get to the survey, and also before you start taking the survey, you need to have your student number available so you can enter that information. Thank you again, and if you have any problems clicking on the Google Doc, just let me know. I appreciate it. Thank you.